Today we are in for a real treat. We have Dr. Cheryl Boyer, who is with K-State as a professor and extension specialist in ornamental nursery crop production and marketing. Basically, she knows her stuff, and I will let her address her credentials even better than I can. But today she was going to address something that we all have. Even as master gardeners, we enjoy our container gardens, our potted plants. I know I have several in the kitchen, and I will have lots of questions for her because sometimes we have everything from a basic household plant to succulents and so forth. So I'm sure they all have different needs. And what she's going to address today that deals specifically with potting soil, the type that you might find at a garden center. And that is something we don't always address. So I'm looking forward to hear what she has to say. So let's give a big round of applause for Dr. Boyer.
All right, let's get hooked up properly so you can hear me, maybe. All right, is this close enough?
Yeah, that's good.
Even if I turn my head that way?
Yep.
Okay, great. Hi, welcome. I am so excited that not only did you guys ask me to talk about this, but you're still here. So thank you for that introduction. My name is Dr. Cheryl Boyer, and I am a professor and extension specialist at K-State, and my area of expertise is ornamental nursery crop production and marketing. So I am from Oklahoma. I have an undergraduate degree in landscape architecture and a master's degree in nursery crop production. I work with Greenleaf Nursery in Tahlequah, Oklahoma, and we sprayed pesticides on plants to manage Colototricum on Euonymus fortunii, which is a super boring plant, but I can tell you how to manage it. And then I had an opportunity to go to Auburn University in Alabama to pursue a PhD, and the project that was available was on substrates. So I didn't know anything about that, but we did 10 replicated studies in 3 years. So I picked up a lot. And this presentation is sort of a mix of like the big overarching theme. So I'm super excited to hear about your questions. But my first thing, let's see if I can get the slides to advance. It didn't work a second ago. There we go. Just this. Your magic. Okay, I want to see, show of hands. Have you ever read the label on a bag of potting media? I'm so impressed. Look at you guys. That's like more than 50%. I'm pumped to see what you guys have picked up and what you're learning. There's a lot going on a bag of potting media, and as you'll see as we go through, some of it is more useful and descriptive than others. And hopefully by the end of this presentation, you'll have a better idea of what you're looking at and what you're going to buy. Well, I got this question. Did anybody bring a bag? Like an empty bag of potting media? I did ask them. Okay. All right. Well, if you have those questions, I can't wait to hear your questions. So I am pretty adept at filling the available time. So if you got, I'll try to save time for questions because I can talk about potting media for a real long time. I can nerd out. Okay. So try to stay in front of the camera for you guys online. We're going to talk about understanding soil-less potting media. So in just a second, we're going to talk about why you don't want soil in a container. And it happens. I think as extension master gardeners, this is like one of the easiest and best things you can do for your neighbors because they're likely buying whatever is least expensive and they have no idea what it is. And then they put plants in it and their plants fail. And they just think I'm bad at horticulture. I'm bad at gardening. I'm bad at plants. And that's not true. We can just give them a little bit of information to help make a better decision. So we're going to get a little bit nerdy with the physical properties and the chemical properties. And I'm going to share with you some of the things that I do as a scientist, as a substrate scientist, and how you can maybe learn to practice some of those things in your own gardening, or at least knowing about them is helpful. Then we'll go into some components, the big major ones, some minor ones, and some specialty ones. And I did bring some samples. It was fun to dig around in my lab and bring some things for you guys to look at. So we may just put them up here at the end if you want to come look at them, but there are always lots of questions. Well, when I get to talk about this, people don't always know what they all are. And I'm excited to tell you what we're doing that's different in Kansas. So there's different ways to use potting media. There's different, and it really varies based on container size and plant. So a lot of this presentation is a whole lot of, well, it depends, right? It's a good horticulture answer. It depends on what you're growing, what size container it is in, what is your objective? Is it short term? Is it long term? What are the needs of that particular plant? So that's where we get to dig deep and learn a whole lot more about the horticulture that we're doing. But we're going to focus on containers and a little bit on landscape beds. So understanding soil less substrates. This is a picture of a planter I had years ago. And, this is what you're going for. Healthy plants, dark, deep green, they're floriferous, they're filling out the container and it's appealing. But it can go bad pretty quickly with just not a lot of knowledge. And I took this firsthand. My children are now 15 and 11, but their childcare provider, when they were really young, was guilty of buying the cheapest bag of potting soil and putting it in front of her yard, and it seizes up like concrete. And it is so challenging to explain why, if you're going to put field soil like that, and this is a photo from the soil diagnostic lab on campus, all the different types of soils that they see, you can see that it varies widely across the state, across the country, across the world. So it's not just a matter of going out and digging up what's out there or purchasing the least expensive. But they do have some requirements. So first, you're thinking about what is the weight on that container. So field soil is really, really heavy. And it does surprise me in the agronomy part of our university, we share greenhouse space. They're all using field soil. I'm like, how? But they're looking at wheat and sorghum and other scenarios. And that is sort of the crop conditions that they're in and that they're designed to manage for. Because if you think about a plant, its whole world is what's in that container. If you don't provide it for them, they don't have it. And it can make the difference between something doing well and not doing well. So if it's super heavy, that's actually hard for you and me to pick up, right? Depending on the size of container. So you want something that's lightweight, but not so lightweight that in our Kansas winds, they're going to blow over all the time. This is actually a challenge in nursery crop production, is when you're trying to grow a pretty big tree and they're in full leaf and we get a Kansas wind, they're catching all that wind and they don't have the structure in the ground to help them stay upright. So there's all sorts of different systems that have been created to help solve that problem or at least minimize it. Generally, nursery goers are always picking up plants and garden centers are always picking up plants, but they try to come up with systems to minimize that. But they're not going to grow a really large tree in peat because it's too light. So they have to figure out what makes more sense for that kind of a crop. But the biggest problem, I would say, with soil is that there's not enough airspace. So there's not enough big chunky parts for the roots to get down and be able to really explore and take up space. So you need something that will give it structure, will allow it to hold water so it can take up water, and to hold food. It needs some nitrogen and some other nutrients. So it's got to be able to hold on to those things and not be too extreme on one side or the other. So often some of the challenges with field soil, you don't have enough airspace. It might not hold water or it might hold way too much water. And those are both opposite ends of a big challenge. And sometimes for what we need for an annual bedding plant type of container or a houseplant container, you need it to hold food, to hold what the nutrient holding capacity. And field soil is really variable and it really depends on soil pH. So thinking about what you have access to and what your objective is will really make a difference. But that's like one simple thing. If you can pick out the people who are putting soil in those containers and help them, you will have made a huge difference. So what are some of these physical properties and how do they dictate how much water and oxygen are available to roots? Sometimes you'll see a potting media like this, and this is an orchid. Orchids actually kind of prefer to be a little bit dry. They like a lot of airspace. So you can see this is actually a fairly small container, and it's got really big chunks of pine bark that are used as the primary media because that plant wants more airspace. you typically this is probably a 4-inch container. You would not normally put something quite that big, but this plant needs it. So it really depends on what you're growing. And how do we determine that? So this is a fun treat of a picture of me 20-ish years ago. And we did a lot of physical properties. So we mixed lots of different potting media. I was able to do some of the early work when we were first beginning to look at wood-based substrates. So up until that time, pine bark was the main material in nursery crop production, because when it was first noticed as a waste product of the paper industry, it was piled up on those facilities, and they would catch fire and be a problem. So they were looking for ways to use it. Well, over time, they've found lots of uses for pine bark as fuel and other things, and there's more and more competition, and in changes in practices, it sometimes is less available. So what were some materials that we could begin to evaluate that were more abundant? And the material I worked with was a product called, we called it clean chip residual. And that was when the forest industry would go out into the forest and they would thin the plantation so that the remaining trees could get larger for lumber. So they would take the sort of small caliper trees and run them through a machine that would essentially strip off all of the bark, all of the branches, all of the cones, and that was waste. And so they couldn't figure out what to do with that, because the product that they needed to make paper with couldn't have any bark in it. So if it had bark in it, they called it dirty chips. So they needed clean chips to make paper products with, and everything else was a waste product. They didn't haul it anywhere. They left it in the forest. So we went out and collected samples and figured out, how can we go from, and you guys know lots about composting, can we go from a tree to a pot in a day? We can. It takes some management. And now wood-based substrates are becoming more and more mainstream. But because in order to get there, we had to do lots of tests. So we collected these samples, we processed them to different particle sizes, which I'm going to show you in just a minute. And then we would come along and do these tests looking at bulk density and airspace and pH and electrical conductivity and other things and we would grow crops in them in different mixtures to see what would work. So this is a tool called a pyrometer that was developed by North Carolina State University, and we pack it in and fill it with water and then let it drain. So that is how we're trying to get at the bulk density in the airspace. So bulk density is how heavy is it for the volume of space it takes up. So thinking back to that orchid mix, that's big pieces of pine bark, it's probably really light. Those are going to be produced in a controlled environment in a greenhouse, because we cannot have wind be a factor, because they will all blow over, right? So it's very light for the amount of space that it takes up, and so is peat. But sometimes we have more dense products, and we just need to know how those factors influence long-term, whether or not that substrate is going to work. So in general, in container production, lighter is better for the most part. We're trying to avoid those really heavy soils, but sometimes we'll come back and add a component like sand, and that really mostly is for weight. So airspace, you want to make sure there's enough to allow the roots to grow, but not so much that they don't have anything to hold on to. So there's a nice balance in there. And so I have lots of tables of data full of that. This is what this looked like. So this is clean chip residual, and does this work? So the top one is my favorite size. This was a 3/8 inch hammer mill product, and you can see we could get finer and finer, and that is going to change how it fits in a container. So if you think about it, if you had one of those really fine ones in a container this big, it would probably nest and sink down and be a lot smaller over time than something that has bigger, chunkier properties and will more slowly change the physical properties over time. So you really have these particle sizes go from very fine to very large, and you've got all of that sometimes in the same product mix. So knowing how much small particles versus how much big particles you have makes a difference in knowing whether or not it's a good one. So your ideal mixes change depending on the plant sizes and the size of container. So their preferences and the size of container. Also think about how those particles will nest. So how they settle next to each other over time and what's most appropriate for the size of container that you have. So how we determined that was with sieves. So these are cylinders. They have different sizes of mesh. I don't know if you can tell, but the one over here, those are like 1-inch grids. And sometimes we would get big branches that would stop at that one and would not go through. But as you go smaller, I usually had to do 2 stacks of them to get really, really fine and figure out how my mixtures were hanging out. And then this machine is the separator. I have one of these in my lab in an enclosure. We don't run it during business hours because it's super loud. This big bar up here at the top, it just bangs like this. Physically just bangs. Cheryl's working again. But that's scientifically how we're measuring these things. You're probably not going to do that. We're going deep before we go a little bit lighter. So more physical properties, you're thinking about total porosity and airspace. So total porosity is the complete volume of pore space expressed as a percentage. So generally you want 50 to 85% of space for those roots to get in there. You want a loose substrate, so there's room for that. Airspace are those macropores. They're air-filled large pores from which water drains following irrigation. So 10 to 30%. There's lots of different ways to get some chunkier pieces in there, and they're really to create some of those macropores. But something you might not know, you know what? We're going to talk about that on the next slide. That things change over time. So water holding capacity is a really important part of physical properties. So another term for that is container capacity, and that is the maximum amount of water a substrate can retain following irrigation and drainage. And sometimes you have what is called a perched water table. So down here at the bottom where it's really, really dark, oops, what will often happen is you see your container, right? And you stick your finger in the top a little bit, right? You're like, ooh, it's dry. I better water it. Don't we all do this? A lot of times it's super wet in the bottom. And so that bottom part can become anaerobic. It can begin to cause roots to rot because we're not testing the whole thing. And I learned this the hard way. We all make mistakes, right? Got to own it and learn from it and change. But when I was doing my PhD, I ruined an entire study because I didn't know how to water. They said, water it every day. So I watered it every day. And my professors came out and they were like, what's wrong with this? And they walked around and they started lifting pots. These are really wet. How often do you water these? Every day. I hadn't had a greenhouse class, so I didn't know that in the greenhouse you really needed to be checking that. So one way you can check your container for how much water it has is to pick it up and get it, if it's small enough, and get a feel for, is it heavy? Because it's probably holding some water down there on the bottom. But the way we would measure that would be, that's part of that process I was showing you earlier for, I think I have some instructions for you in just a minute for how you can sort of figure out what works best for you in the containers you have. In the small ones, if we're talking about big commercial landscape ones, that's probably not what we're going to do, but we have some strategies for that. So it's also important to think about water being available or unavailable for plant uptake. So sometimes, especially in soil, this happens with fertilizer too. Sometimes the soil just holds on to stuff, and no matter what the roots do, they can't break through to get to it. And sometimes in our potting media, especially the plants, the house plants we've had for years and years and years, sometimes the water that we put in there isn't reaching the entire root ball. It develops a process where they develop channels through the potting media, so it drains really fast because the water's just going through those little lines that it has created over time, and the whole rest of the root ball is dry. I'm convinced I have that problem at my house right now. And my neighbor, our state 4-H program leader, she wants to repot some houseplants. So I think we're going to repot some houseplants for both of us. And knowing that that is a possibility and that could be what's happening is part of being a plant detective, right? So it's just another tool in your toolbox. But in general, 25 to 35% of available water is ideal. So you don't want it to be super high. You want it there to be enough for the plant, but not enough that it's drowning. Okay, so this is a little bit more about that with the container dimensions and where the water goes. So the dimensions of the container can really change how the water moves and interacts within the confines of the space. So this is a photo I took at a nursery in Florida, and you can see that that container is wider and shorter than maybe you would think would be necessary for a tree that is that big and that is filling up as much of the container. In this case, palm trees actually require very little root volume, and it is an appropriate sized container for that tree. But it does change how the water, where the water is and how the water stays in that container. So you can see, just like we were talking about earlier with the perched water table, oops, the lowest water content is at the top where we're checking, and the highest water content is probably at the bottom of the container. Now there's different ways of approaching this. One of them in production is to water from the bottom. So you may already do that with some of your houseplants, or you may soak them in your sink to really get them to go past those channels and really fill it up. But in production, sometimes they'll have systems that flood the bottom of the pot, and it works for some plants and not for others. You've got to think about the fact that if you have a pretty big container and you put still not the right one, you put a little bitty small plant up here, it can't reach what's in the bottom of the container right away. So you have to make sure that you're watering it at the top until it gets established and it can send down roots. And that's actually really good. Like, tell it to go explore and get resources. So watering from the bottom can be a way to approach that challenge as well as the pot matures. So this is one of the studies I did here in Kansas we chipped up eastern red cedars. Talk about getting rid of invasive, challenging plants. We can grow in them, but none of my growers were interested. So when they begin to have challenges with their substrate supply, I'll be here with some instructions if they want to try it. But you can see it's a really sandy mix, and B, we're growing a grass. So grasses grow fast, they fill out a container fast, they use lots of resources, they like lots of water. And even in a crop like that, you've got a perched water table at the bottom of the container, which can be a real surprise. So it can happen to just about anything. Okay, this should be familiar. This soil nutrition, how pH affects the availability of plant nutrients. We know that in Kansas, we tend to have a pretty high or alkaline soil, which is a problem primarily for iron, right? So we get iron chlorosis when there's not enough iron. pH is a major issue. So field soil in Kansas is generally high in pH or alkaline. So this matters if you're doing a landscape bed. It also matters for containers. We'll talk about that in just a second. But the reason for that is that most substrates are low in pH. So this was interesting to me in Alabama. They had completely different production problems. So most of their soil is acidic. So it's over here they have a different set of problems with what's available and what's not available. Pine bark is acidic. Peat is pretty neutral, which is why it makes a great potting material, but there are a lot of materials that are acidic. So if it's a potting media that's produced in that part of the country, they're going to add lime because they're trying to raise that pH up to neutral. Well, guess what? We got plenty of that here. So sometimes it's actually better to start with a plant that doesn't have that material, or a potting media that doesn't have lime. That's something you're going to look for on the label, because much of our water is alkaline. So over time, it's going to raise the pH of the potting media, of the container, of the landscape bed naturally, just from you applying our Kansas water. So lime is not something we necessarily need in Kansas, but it is a very common additive to potting material because they're trying to raise those naturally acidic materials to more neutral, whereas we're coming from the opposite spectrum. Okay, chemical properties. So I mentioned EC, that's electrical conductivity or salts. Usually too much means you put too much fertilizer on it and it can burn plant roots. So as you're being plant detectives, if you can figure out, if you can take a measurement and learn whether or not salts are the problem, you can repot it and start over with a little bit fresher of a salt perspective. A flip side of that is if you have too low, it means that you're watering too frequently and you're leaching the nutrients and they're going someplace else. So that is a tool to know whether or not the material that you're using is working or if you need to make a change to your practices. More chemical properties. How do you test at home? So there's a lot of different ways to test for pH and EC and salts, but you probably don't need to know all of those detailed ones. But one of the most practical things that we did, that I did this about a million times, is the pour through procedure. So essentially what that is you have your container, you water it until it's well watered and you let it drain for an hour so that what's in the container comes to a state of equilibrium. That's what the plant is going to use. And then you would come along. In this case, we've got just your standard plant saucer. This has just a cut PVC pipe to make the pot sit up off of the saucer a little bit. You could also use a brick or something else like that that's inert, that's not going to cause problems. And then you pour some water on top. And what that does is pushes out the water that's in equilibrium in the container. So then you can collect what falls into the container at the bottom after about 5 minutes into a bottle. And if you want to send it off for analysis, you can do that. If you want to have a home testing piece of equipment, or Sharon, I don't know if you have pH and EC meters here. They're something the group might consider as an investment. They're not very expensive, about well, it's been a while since I checked, but closer to $100. And then you could just come in and check and get an idea for your sample. If you can get, that's a different discussion, but there are ways for you to figure that out if that's what the problem is. But this process is actually pretty simple for containers that you can actually pick up, right? So that is what we did lots of. Each component in the mix changes, both the physical and the chemical properties. If it holds more water, or do you want to increase the available water? Does you want it to drain better? Maybe it's leaching pesticides and nutrients. There's pros and cons, flip sides to all these scenarios. Is it heavier? Is it lighter? Does it raise or lower the pH? So as you think about the individual components and what you want it to accomplish in your mix, those are the things you're trying to influence. So this is an example of a study that I did. And I can't remember if this was an Eastern Red Cedar or Clean Ship Residual, but again, you can see the water changes in the container, but also what you're looking at is how well the plant has rooted out and whether or not it likes the material that it's in. So this bottom left-hand corner one, the 1,5, is a standard peat light mix. So the roots have really expanded. They've filled out all of the space. And if you look in the photo on the bottom, that petunia, that's probably the one you're going to purchase, right? It's probably the one that looks the best. So this was an early on test with some of these products. And, a petunia will tell you real quick whether or not it's happy and it's getting what it needs, and if you need to make some changes. So I'm pretty sure this was a scenario where we went all the way to 100% on this wood-based substrate, and it was not having it, did not like it. So we've got to come back and figure out, well, what ratio can we use it in so that we can get something that's a little bit more acceptable. But you can also see this is 5,5, so that's this one. We see that dark zone in the middle. This is the middle picture for those of you online. That is an anaerobic scenario. So those roots are actually rotting because the potting media is holding too much water. So there's all sorts of variables, and you should not be afraid to take a plant out of a container and look at its roots, whether you're at the garden center or you're at home and you're trying to investigate what the challenge is. You just put your hand over the top of the container, just try to hold the soil in, put the plant between your fingers, and then turn it over and tease it off. And then you can have a look at what's going on in those roots. Some container shapes will not allow that. We'll say that. But for the ones that you can't do that, you can have a look at it and see what's happening to the roots. Generally, you want to see white, healthy roots that fill out the container. And it really matters for a house plant or a bedding plant. Root structure is not nearly as critical as it is for a woody plant like a tree or a shrub. In which case, you got to deal with those circling roots, right? Okay, so potting media bags can be confusing. You might buy field soil or something of poor quality. And so what should you look for? I was just not very impressed with this. This was mostly perlite and vermiculite. And actually, this is one of the samples I brought. I personally bought some potting media this last year. And I was like, this is literally the worst potting media I've ever seen. There's hardly any peat in it. It's mostly perlite. We haven't even talked about what those components are, but we're going to in a minute. And I thought, this is going to be dry. It's not going to hold water. My plants are going to struggle in this. And sure enough, they did. And I couldn't wait until I used up all of that I had purchased, that it was not what I expected to come out of that bag. Not ideal. So what are those components to really focus on? So again, we're back to soil less. We're avoiding soil for substrate components. You can again see this was one of my clean chip residual studies. So our major components are bark or something that like composted forest products. That looks different in the industry just about everywhere. You've got the people that are in the forest harvesting forest products. And then you have sort of the middleman who's coming in and getting the leftovers, and they take them to their facility. They age them in different piles. They turn them regularly to compost them, and they have more or less bark versus wood or other products. And sometimes they separate it out by tree species. I don't think I have a picture of this in here, but one time at the Pear Station in Hayesville, we were able to get a tree care company had been working in Osage orange. So that's Maclura pomifera. They had a whole load. They knew for sure this is all Maclura pomifera. It hasn't had any pesticides or herbicides or anything on it. Do you want it? We were like, yes, I want it. And sure, so because Maclura pomifera is used for fence posts. It doesn't decay very easily. And I was like, this is going to be fun. And it super surprised me that it shrank in the container significantly more than Eastern red cedar. After we chipped it up and we processed it and treated it all the same, sometimes you can just never know. So testing each individual species is what helps. In the South, a big pile like this, these are my two doctoral advisors, Dr. Glenn Fain and Dr. Charles Gillum, standing on a pile of this residual material that we were getting, loading up loads of and running it through a chipper. And that was loblolly pine. There's a lot of loblolly pine in forestry in the South. It works really great. Around here, we don't have that same consistent supply. And sometimes they would be in a plantation that had Virginia pine. So does Virginia pine behave differently than loblolly pine? So there's a lot of science that goes into, well, which one is the ideal one and what do we do to it to make it work? Peat is another major component. You're going to see this in your bedding plant products. You're not going to see it in nursery, in bigger tree and shrub kind of containers, not usually, because it's more expensive. It's almost all harvested in this part of the world. It's coming from Canada. European countries have their own peat bogs over there, and they are light years ahead of us in reducing their peat usage. So the peat producers in Canada, it is actually a renewable resource. It's a very slowly renewable resource. They're very, very responsible managers of that resource. We still don't, they only harvest a small percentage of it every year. But nonetheless, if we can, the freight is often a big challenge on something like that. It's expensive to ship it here. And it's not like we have pine plantations everywhere in Kansas either. So if we're getting a pine bark product, we're almost always having it shipped here. So we're paying for fuel to get us these materials. And it really just depends on what they are and where they came from. And on peat, back to peat, The bag might include what type of peat, which generally refers to the source material, where it came from, or the coarseness of the material. So I'll explain more about that in just a minute. But bark and peat are your main ones. Peat is going to be bedding plant, house plants, not outdoor trees and shrubs, and bark will be most of the other. But you can use bark in your other mixes, as well as some wood-based products. Some other major components, you might be thinking about using manure. This picture is from Auburn. We had an in-vessel digester that could take all sorts of different wastes and turn them into material that we were able to bag up and sell as composted, because we were able to trace where they came from and what they had been treated with. So any kind of manure, we know, especially if it's composted well, it's gone through a heat, it's a good source of nutrients, but you don't know what those animals ate before it became manure. And sometimes you have to have records that track the fields that they were, eating grass on, and what herbicides were used to treat that, because a lot of herbicides can have a long-term residual and they will go through the composting process. So there is nothing worse than making your whole landscape bed, pulling in some compost, tilling it in. This actually happened to me last year. I was very disappointed because I bought a product I had used before. It was a cotton burr compost from my local independent garden center, and I put a bunch of bags in my backyard because my husband decided he was ready for a vegetable garden, which when the husband decides he's ready, you go, right? It's got some help. And so I knew that the soil quality was really poor back there. So I got a bunch of compost and I put it on my garden, and my tomatoes had herbicide damage, and I didn't get any tomatoes last year. And I was really disappointed. And that was because at some point back in the process, a herbicide had been applied to that source material that persisted through the composting process. So I can only hope that this year it has leached out and worked its way through the system, or I can come back with another product to try to even it out a little bit. But if that happens, there's your detective mind. What was happening in that material before I got it? So you want it to be fully composted. It can cause rapid decomposition. So microbes are very happy in there. They are looking for ways to dig in and break things down. So that happens in containers too. So when I talked about the Maclura pomifera shrinking, this also happened with some of the alternative materials that we used. And I'll talk about that in just a second. It's actually something I measured was shrinkage, substrate shrinkage, how much. Okay, so sand, we talked about that earlier. It's generally for weight because it's pretty inert. It does help with drainage as long as it's a reasonable amount. It's not too much, but it doesn't hold nutrients, not well at all. So there are some purposes for it. We used it in class in propagation experiments because it doesn't hold nutrients. So whatever you put on there, those tomato plants would show you all sorts of different fun nutrient deficiencies and toxicities because what was in the sand was not enough to keep it going. Okay. So there are some, on a major components category, there are some alternative materials like coconut coir, and it's exactly what you think it is. It's a byproduct of coconut production. Wood fiber, we've tried eastern red cedar. Some less common alternative materials. My master's advisor worked with a product called fluff that was legitimately garbage. Like they ran it through some processing, so it looked like cotton candy or lint from your dryer. Strange material. Well, I love alternative material waste products that we could throw in a container. By and large, you can generally go up to about 25% of any kind of alternative material as an extender, as an amender, but you can't replace the whole thing for the most part. If you're thinking about tires, you absolutely want to avoid those in your landscape. Toxicity, they've got zinc in them. Bad news bears for potting media or for plants of any kind. Do not use tires. We've used grass, corn stover, poplar, bamboo. I had someone send me some alfalfa once and some corn. Yep, I've tried corn stover. I have a picture here in just a minute of in Hawaii. They have volcanic rock in abundance. So that's what they use. And I had a lot of questions about, does it hold nutrients? it's almost, it seems like it would be fairly inert, but they were using it for all sorts of things. In Alabama, we would get brand when it got there, right? Then it turned nasty. Somebody brought spent fish waste. It was so gross. That was not my project. I was like, I'm not touching that one. But or anything. And then I looked down, I'm like, oh, there's like a feather. I wasn't expecting that. And as you can imagine, with that particular product, that was one that when I used poultry litter, the shrinkage was crazy because there were so many microbes in there. They decomposed the source material really, really fast. So there's definitely ways that is of usefulness if you're going to use one of those products, but just know that's why a lot of times when we talk about planting high for your land time as things decompose and the air settles. And if you're adding a lot of compost to that, that's where that might be coming from. Now, we've gotten a fair bit of questions about biochar lately, and if you watched January's K-State Garden Hour, there was some questions about that because you're seeing it more and more in the news as it's a byproduct of the pyrolysis process, and I have lots of colleagues that have done work on it. But we, first of all, don't have a lot of it as a source. I'm thinking you might see it on a container as, ooh, this has biochar. Well, biochar tends to be, no matter what the source material is, tends to have a high pH. So it's the same as pumping some more lime and calcium. So for us, biochar doesn't make a lot of sense. But in the South, where everything is low pH and they're trying to bring the pH up, so think about where it's coming from and filter that information. And I'm so glad you guys asked those questions. Volcanic rock in Hawaii, they were using this. You can see there's some different chunk sizes in there. It's clearly been aged for a long time. This was at their potting bench and they're growing plants in it. And these little prills, these little bitty prills, those are fertilizer pellets. So it's holding nutrients at least so the plants can grab it pretty quickly. They were also doing in-ground bed cut flower production in this material. So I always think it's fascinating to see what we can use that's local. So some minor components. We've got perlite. Well, it's for aeration. It's for getting airspace into a container. It's not for fertilization. So I have a colleague who once was walking down a big city street somewhere and somebody had dumped a whole bunch of this on their planting bed and they were really proud of themselves because they thought they had fertilized, which if you put this much on top of your landscape bed, you're going to burn it because you put too much fertilizer, but also it's just perlite. In these mixes and they think that's fertilizer. It's not. So that is something you can help your neighbors with, is educating them on this is for airspace. That's actually a big use that we found for the wood-based substrates is that those chunkier bits can really be more effective for airspace and than this type of product. So, different sources. Vermiculite, that's the one on the top. It's a very fine material. Both of these used a lot in propagation, where you're really just trying to get plants to put on roots. You're not necessarily manipulating them with fertilizer, so they just need some structure and some air and some water, and you're putting mist on it regularly. So that is what helps roots initiate. You might also see rice hulls. The University of Arkansas pioneered a lot of that work, and it can be used for aeration, but most of the time I see it used as weed control on the top of nursery containers. Sometimes they still have viable rice seeds in there and you'll get a little bit of rice growing up. But for the most part, they do keep weeds down. So you may, if you see that in the top of the container, that's what that's for. It's not often mixed in, but it can be. Some specialty components, you might see products like mycorrhizae. So there are some products that offer you a plant guarantee if you purchase a product and you apply it to the soil. It's a nice feature, but in the soil, it's actually not necessary because there's already, unless it's a really barren soil, we already have tons and tons of native mycorrhizae everywhere that already do that. So it's not necessary, but it's not going to hurt anything if you want it. In a container, they're very, very helpful because, again, you're providing all of the resources in here, and something like a pine bark that's taken off of the outside of the tree is not going to have interacted with the soil to bring in some of those native microbes. But what the mycorrhizae do is it's a symbiotic relationship where they sort of infect the root. But what they do is then they extend the reach of the root. So they're going out and getting water and nutrients and bringing those back to the roots. So it generally increases the health of a plant in a container and in the ground, but it's not totally necessary in the ground, but plant guarantees are nice. And you might also see a fungicide. So a lot of times we have lots of issues in container production, and fungal issues tend to be some of those. So you might end up with a product that has a fungicide in it. They're generally very safe and very good additions to a bagged substrate product. Other minor components, you might have a pH manipulator. So again, you're looking, where did this come from and how are they manipulating the pH? If they're putting lime in, they're trying to raise that pH. If in Kansas, we want to look for something with aluminum sulfate or sulfur, that's going to lower the pH, or nothing, right? So you don't, if you Google information on this, they'll probably say you want lime because so many big parts of the country want lime, but in Kansas, we don't want it and we don't need it. It's not going to hurt things, but it's not necessarily helpful. So if you can avoid it and pick something else, that's probably a little bit better. For organic products, they're not any better or worse than others. So the key here is that most material that's in soil as potting media is considered natural, and it's very likely produced using organic processes, but applying for that certification and having the inspections done and maintaining it is very, very expensive. So for a low cost product like a potting media, it's the trade-off is often not worth it to become a certified organic product, but probably a lot of what you're purchasing is already of that nature. So yeah, make sure they are free from herbicide residue is the biggest key there.
Is that more likely in the organics, so you're not worried about a dicamba ready cotton like you got?
And if they did certify a product like that doesn't have the herbicides like you were just mentioning, yes, that would make the use of an organic product ideal, because you can be absolutely positive, but most of them aren't using it. It's just going to be more expensive essentially, but there are cases where that is really important to confirm. Yes.
What is the pH of peat?
The pH of peat is actually pretty neutral. It's around 5 to 6. And so that's why it's one reason why people like it as a potting media, because it is right sitting there in the middle and it can be manipulated one way or the other. So it's hard to get away from peat because it's so ideal in so many ways, but to be more sustainable, we need other sources. It's core, yes. I think it's pretty close to neutral. I would have to look up that one for sure, but it's a different texture. So yes.
Isn't 7 neutral, not 5 or 6? That would be low pH.
Yes.
Right, it's kind of in that range for sure, but 7 is a little high, I would say.
That's neutral.
That's neutral.
But if we're adding water on top of it, it's going to keep raising the pH over time. So be a challenge. Yeah. Yes.
So when you have the biofungicide and mycorrhizal in the same bag of soil, isn't that cross purposes?
It depends on what they're for. So a fungicide and a biofungicide is going to target very specific organisms. So if they have it in a bagged product, they're going to choose things that the fungicide is not going to impact the mycorrhizae that they put in there. So it's not going to have any action on it, if that makes sense. So they've,
Yeah,
right, what?
that's all I'll take your word for.
Right. We have to trust that they've figured that out, but we a little bit too much. So you guys can have some time for questions. Some uses, this is a load of compost that came from the university dining halls on campus, and it had a lot of trash in it. It was interesting. So pros and cons, it was free. my friends brought it over, but you had to pick little interesting pieces of things out of it. Okay, so for small or medium-sized containers, you're going to want to make sure it's fine. So primarily peat, that's the big key for a small container. You do want some larger chunks for aeration. So, and you can even mix that back in. So depending on if you get a bagged product that is super fine, you can always buy some pine bark and mix it in yourself so that you can get more of that aeration. But in general, you're looking for something that's pretty fine because it's a small container, unless you're growing orchids and they like the big chunks. For larger containers, you want to choose a material that's pine bark based for better drainage. And this is an example of that. This is a commercial container that is quite large. So you definitely would want this to provide better drainage. In fact, it's so heavy, there's probably not effective drainage holes in the bottom of it. So you want to make sure that if you have that perched water table in it, it is manageable. But there is another strategy I'm going to tell you about in just a second. Some other information about extra large containers, you'll almost always see this in nursery crop production. It's not super common anymore to have these wooden containers, but a lot of commercial landscape situations will have really big containers like this that really need to be grown in pine bark based material with a much higher chunk or percentage of coarse chunks, so that if it's very fine, you don't want it to sink through that container over time because of microbial action degrading it. Because like the plants will probably be in those containers for a really long time. They're probably woody and they're not going to be changed out very frequently. So with annual bedding plants, we're often taking those out of the container and switching it up on an annual basis or more frequently. And we have the opportunity to address potting media issues at that time. But for the more permanent things, it's a longer term solution. So this is another commercial bed that's got some mulch on top of it, but it should be a more coarse pine bark based media. And these are perennials, so they're going to be in there for a little bit longer. Those are like really big containers at a nursery. So you can imagine you'd want a pretty coarse material for something that large over the long haul. The newest research on substrate work is with stratification. So this is interesting because on the production side, what you're seeing are mixtures of, and this is from Jeb Fields. He did this work at LSU, but he's at Florida now. And you've got a perlite mix, which is sort of a peatite mix, which is sort of your standard, peatite and pine bark, peatite and wood fiber, coralite. Core is that coconut core with pine bark, and coralite with wood fiber. So what they're doing is this first study is like a 50-50 mix, because with an annual, we just talked about the water. You got to water the baby plant until it establishes, and you don't want it to hold water at the bottom because you haven't gotten it there yet. So if you can put a less expensive material on the bottom and put your more expensive material at the top, you can save a little bit of money. But where I think that it gets interesting for us is if you think about those big containers and our containers that are maybe, this big, what if you put pine bark mini nuggets in the bottom half of that pot and you put your peatite in the top so that you don't have that perched water table, it drains a little bit better and it's not as heavy. So I'd like to see them do some bigger container research, but I think those are some applications that homeowners can apply right now. In landscape beds, this was at my house when my daughter was 5. Constant companion she was during 2020. So the builder had just put like a ton of rocks in there, which took 1,000,000 years to pull out. And then it just was this muddy mess. So I had to figure out what I was going to do. So I knew that I needed to amend the soil. It needed better aeration. It needed more organic matter. It needed to be mixed and tilled very well. Getting a soil test is really helpful from this process, and having a fertilizer strategy for what's happening there too. So in this case, I did actually purchase a soil product to go in that bed because it needed better soil. And in this case, I was able to purchase a local soil, which was pretty cool. So if you can find something like that and it's in a big landscape bed and you need to add some soil, that'll improve things for you. Then, mixing that in very well. I also bought some cotton burr compost that year, didn't have any herbicide issues with it. And it really did make that soil go from that muddy pit to a really nice mixed product until you hit rocks and have to stop. But everybody does that, right? And, raking it over, smoothing it out, and coming back and checking it over time. And shopping with 5-year-olds brings home lots of interesting things. We figured it out. And then this was that landscape bed that year. It's really fun. Now I have some woodies in it, but I got to change it out every year and it did really well. So just from that same day that you saw just a second ago to about a month later, it really filled out. I came back with some mulch and some fertilizer over the top of it. And there's different types of fertilizer to think about. So you've got your prills that are long-term release, good stuff. They release at different amounts of time. You can have a 3 to 4 month release or a 7 to 8 month release. And depending on how hot it gets that year, that's the function that makes it turn, tells you how quickly it's going to release its fertilizer. But there are also liquid products or products that are mixed in. So one of the things you want to look for on your bag of potting media is something called a starter charge. This is often mixed in. It's not going to look like a fertilizer prill. It's something that it's a liquid that they have sprayed on there during the mixing process, the bagging product at the store. Starter charges are great. That means you've got some food to start off with, but you need to know, do I have a starter charge in this or not? And starter charge was a new term to me when I started working with substrates. And now I can tell that they have added some fertilizer and that's helpful. So you've got those two types, control release and liquid feed. And if you need to add more, this is why if you have a product with a starter charge, those plants will be good for a few weeks. And then you need to start putting more fertilizer on, whether that is with a prill or a liquid applied material on top. But you definitely want to apply at the label rate. So watering. I talked about how I learned about watering. Watch your plants, lift them, see if they feel heavy or if they feel light. If you can do drip irrigation, that is wonderful. And in some cases, in really big scenarios, you can actually inject the fertilizer into the irrigation system and have that work well. But we're all learning and we all figure out what works best for the spaces that we have and the plants that we're growing. All right, here's some more examples. I love the marketing on this. Tips for spectacular results. Spectacular. So I'm going to see if I can put the cursor up here. Nope. So they've got some regional formulations, but in general, you've got reed sedge peat. So again, that tells you a little bit more about the peat. To me, that's a more coarse peat than our sphagnum peat moss. It's got aged forest products, composted pine bark, composted rice hulls, and or composted peanut hulls. A little bit of sphagnum peat moss. It's got horticultural, I get the symbols over the top of this, horticultural perlite, ground domestic limestone. It's got lime in it, but maybe not too much. It's got a wetting agent, and a wetting agent is a polymer that helps it hold water a little bit better, and a timed release fertilizer. And this is like the all the bells and whistles scenario. So this one has all the things you could possibly want in a potting media, but you may not always need all of that. This one is formulated regionally from organic materials that might be reed sedge peat, composted forest products, and composted rice hulls. You've got sphagnum peat moss and lime for proper pH balance. And it may vary from region to region. So it's going to look different on all of these products, and most of them have very specific things. So sometimes they'll tell you how much is composted. This one is 45 to 55% composted pine bark, and this one is 80 to 90% composted pine bark. So that makes a difference on what you can grow those plants in. In this one, we're looking at peat moss 15 to 25% versus 70 to 80% peat moss. This one has a wetting agent. It's got limestone and a starter fertilizer. This one's got slow release fertilizer, perlite, no wetting agent. So sometimes remind yourself by looking at all the products around there to see what some of those words are and go, oh yeah, I know what that does, and whether or not it's helpful. I thought this was funny. I don't know why you would want to put peat on a lawn. You can't. I put my like leftover peat on the lawn because that's a way to add organic material. But and they've adjusted the pH with limestone in Kansas. This one is another composted product. Let's see, 65 to 75% processed pine bark, peat moss, composted forest products, limestone, and organic fertilizer. This one might have manure, a wetting agent, and fertilizer. Same bag. Depends on where you're buying it. It might have a wetting agent in it or fertilizer. Yes.
So I have a huge container where I save all the soil from the containers, and then I toss in, my regular soil that I've used for other pots, and it's just in one big container. How do you rejuvenate that? You can use it again.
Okay, I have a slide on that in just a minute, actually. It might be tricky at the home scenario, but I will get to your question. This is one that I would not recommend at all. So this one has aged softwood and aged hardwood. So I happen to know that softwood is thumbs up, hardwood is thumbs down. Not knowing what you've got will make it challenging. And it's got sand. Why would you pay for sand? It's heavy. You can add sand later if you feel like you really need it. So I would stay away from that one. This one was another that just had from a more reputable garden center that had lots of other, just tons and tons of information on there that you can dig into. And then lastly, I thought this one was interesting. It is intended for, it says in-ground soil. Their example there is a pepper. It's organic. This product was like $15 for a tiny little bag. So I think you have to think about what am I trying to accomplish? What are my values? Personally, I'm probably not going to buy the most expensive option, but I'm also not going to buy the cheapest option because of those problems, and finding something in the middle is a tricky bit. Yes.
So I'm so grateful for this. Last year I did research, and I needed some soil for a new bed. And what I ended up getting was organic. And it said, depending on where it was at, it was 85% processed forest products, composted poultry manure, and organic fertilizer. And I grew sweet potatoes in it, and they completely broke.
I bet it had with poultry litter in it. It probably had too high of salts, too much nitrogen. It probably just fried them.
So it's really hard. For example, peat moss was in every single one of these. You think that's a very important ingredient to have in there? Obviously it's helpful.
For a container, yes. For your vegetable garden, no. It's fine. It's not gonna hurt anything, but you probably want something that is gonna be chunkier and add more aeration for something like that.
Yeah. So this is difficult to figure out which one.
And there's no standardization, right? So doesn't help.
You mentioned wetting agent, and there are the ones with the moisture control.
Yes.
Are those worth it?
It depends on your application. Where's it gonna be? Are you traveling a bunch this summer? And what size of container? I would say for like your vegetable garden application, no, it's not super helpful. I wouldn't spend money on that. But for a high value plant that you don't want to die, and that you might want someone to come water if you're traveling or something, or you just want to get it established. A lot of time the wetting agents are great for Like if you're gonna buy a bare root type plant and you're just gotta get it home, you can put some hydrogel on it just to keep it moist long enough to get it in the ground. So sometimes they're an in-between step. They generally don't last super long. And sometimes if you like to water and you buy a product with a wetting agent in it that holds a lot of water, then you might overwater because you've got that wetting agent in there. Okay, I've got a couple of Q&A slides here in just a second because I know I've talked too long. But basically, read the ingredient label to know what you're getting. Find out what you need for the plant and the container size or application you're going to use, and then figure out what meets your needs and your budget. And really, be a discriminating person who looks at it. This one, really, it was just kind of I don't remember what poll question I was going to have in there, but that's my colleague, Brian Jackson from North Carolina State University. We always nerd out on all these materials, and this nursery was mixing their media on the ground. And you can see the green stuff is fertilizer, and they've got like some limestone and some very fine material, right, mixed in with some very coarse material, and they mix it with like a skid steer. So there's probably some contaminants in there, but you do you, whatever makes the most sense for you. So this is a study we were doing right next to a big pine bark pile. And I do have a couple of FAQs that get at your question, and then I'll be happy to take as many questions as you all have. So can I use an old media if I have a whole bunch of it? You can. You have to pay attention to moisture. A lot of times, especially with peat, it gets dry, and it's really, really hard to get it to re-wet. You can do it, get a wheelbarrow or something and just soak it and mix it, come back later, mix it some more until it starts holding water again. Unless sometimes media gets, and pine bark does this too, especially in big old piles, they can get a fungal growth on them. And sometimes in big compost piles, it's about a foot in to the compost pile, and it makes a hydrophobic layer. So the stuff, that's why they have to turn the piles, because otherwise the stuff in the middle doesn't get wet and it gets super dry and it repels water. So you have to make sure you're mixing it. Sometimes that can happen to our bagged products. You can work through it and mix it with other stuff. But the water retention is the biggest challenge. And if it's an old bag of media, it's very possible that the fertilizer, that starter charge, isn't there anymore. But you can mix it with other products or add some fertilizer when you plant it. So just an old bag that's just been sitting there, probably a water and fertilizer issue, but totally you can use it. If you're talking about reusing media, so you have a big container of it, you need to be smart about it. So they can hold pests and diseases, they can hold fungi, they can hold insect seeds and weed seeds. They might have some of these re-wetting agents in them or a blend of them. You probably have lost some fertilizer. So can it be sterilized? It totally can be sterilized. This is what we do on campus. We've got steam sterilizer carts. You have to get it up to I just showed that the other day, a very high temperature to kill as many of these organisms as possible, but you can do it in the home environment. There are probably some ways where you can cover it in plastic and let the sun be a part of that process. I'd have to look up some instructions for home, but you can, if you have a big mix, just be aware that there might be some contaminants in there. I typically don't reuse mine. I like to buy it fresh, but my yard needs organic material. So I just throw my used potting media in my yard and spread it around, and eventually the perlite disappears, right? So that is that. Oh, we have questions online. I saw there were like 3 of them. Here, yes.
When's the best time to buy your new potting media for the new season? Because I've often heard that, buying last year's leftover isn't cool.
That's a great question. So for those of you online, if you couldn't hear, the question is, when do you buy potting media? Because there's some concern that buying last year's is not as good. It kind of goes right back to the old bag of potting media. You can totally use it. I would probably buy a little bit of both and just blend them and make sure that the old bag has wetted up properly, and then depend on the new bag for a starter charge if it has starter charge in it, or just make a plan for adding liquid fertilizer, probably to start with, and then top dressing with a more long-term fertilizer. But you can buy it whenever. Sometimes they might have a manufacture date on it. So
Are they required to do that like other things?
I don't think they're required, but it's possible it might be there. So look, that might help, but just in general, if it looks dry and you think it's been sitting there for a while, that's probably just something to manage, but I don't think, I wouldn't avoid it. Like it can, especially, it can extend your stuff and save you a little bit of money. Yes.
Starter chart. Is it a thing? Does it say starter charge?
Yeah, well, it may say fertilizer in the bag or enough food for 3 months or something like that. It might say starter charge. To me, that was a little bit of industry lingo, but it'll say something about fertilizer having been added. And if it doesn't say anything about fertilizer, which sometimes you want, like, when I was doing projects, it took me forever to find a baled peat product that didn't have a starter charge in it. So I could make sure that anything I added was what I was testing. So you just got to look and see what it says. Let's go to one online real quick.
So I do have 3. Where are the best places to buy good potting mixes? Landscape businesses, big box stores, nurseries?
Okay, so best place to buy a potting media. I think you can find good potting media at any of those places. And it really depends on what you need. So if you need it in bulk, you're going to want to go with a landscape supply company that is going to bring you a truckload or a cubic yard bag full, something like that. And a lot of the commercial mixes are custom made, and you might be able to customize something with a larger company. There are good products at box stores and there are good products at independent garden centers. I would say for the most part, products at independent garden centers are pretty uniformly thumbs up, and a big box store is going to have some thumbs up, some thumbs down, and some I can work with that. So they've got the whole gamut, and I think as long as you understand what you're looking at, you can use just about anything that you have access to. Yes.
Question, because a few years ago, we have Central Soy Foods here.
Central Soy Foods?
Soy Foods.
Okay.
They manufacture tofu.
Okay.
We have organic here, and I was getting bags of their leftover stuff and putting that in my cart, and I highly recommend them.
Bags of product left over from the tofu manufacturing process.
Yes.
I mean, I don't know. I'd have to look at it. We'd want to really evaluate it. If you're having good luck with it and no problems, that's kind of a fun idea. It's a local waste product that you can use for an added value application. I think that's cool. Yes.
The various mixes you talked about, peat light and wood chips on the bottom. Wood chips are less readily available, but pine straw is very available. Are they equivalent? Could you put pine straw and then peat light on top?
That's an amazing question. Pine straw I did not think was super available in this part of the country.
It's got Scotch pine.
But if you've got some in your yard, I don't think I've seen pine straw tested explicitly, partially because in a 1 gallon container like that, they're so long and oblong, like the air spaces that they would make in the bottom of the container would be less predictable. So I don't think we have tested that, but you could certainly try. Wood chips you can get from, if you have some chipping done in your yard, you could use those materials. Some
Eastern red cedar boughs.
So Eastern red cedar, the thing to know about that is that there is some alleliopathy in the tree, which is chemicals that make it not ideal for plant growth. But if you cut down an Eastern red cedar and let it dry up, most of that is in the leaves. So once the needles and the leaves fall off of an Eastern red cedar, you can chip that up and it works pretty well. So the tricky bit is, can you get it to a size that works for the size container that you have? You can probably get it from, your tree care company mulch. If you can guarantee that where they were cutting those trees down and that there was no other, if it's a softwood in particular, and there were no other chemicals applied to those trees that could cause problems, you could get that. But otherwise, that does tend to be a production thing, but really the big piece is the chunkier nature of it and the availability of it as a local product. So if you have ideas for things that are local, I'm happy to look it up and give it a shot. And hold on just a second. Let's do one more online question.
All right, so the second one was actually just a comment that a member really likes the Happy Frog soil, gets it locally and likes it. And the last one here is, should soil substrates be moistened prior to putting plants in the pot? Should you moisturize or make sure that the potting media is wet before you use it? Absolutely. You want because if there are any inconsistencies with how well the potting media is holding water, you can do that before you put it in the pot. So get it really nice and wet. If it's dry, a lot of times they come in a bagged product. They can be pretty moist, but sometimes they're not. So take some time, even if you just cut open the bag and you're working with it right here, have a watering can there and just sprinkle some water, mix it up a little bit, then put that in the container. So yes.
So if you're doing some layers of bigger chunks and smaller chunks.
Yeah.
First, is there any problem with the water moving through it? Because in regular soil, if you have two different kinds of soil, you can't get water. So if I'm gonna go out there and I wanna put some sand in, so I gotta get a heavy product, and I want some big chunks, because they had a really big containers we're gonna be using, and I've got trees we can chop up, they're laying down there ready to be chopped right now. Am I gonna run into problems getting the moisture through those?
What are you gonna grow in it?
Native plants.
So is it a bed or a container?
It's in a container.
In a container.
It's a large container.
A permanent installation.
Well, it's big, it's 2 by 2 by 6.
So I would say, okay, so we haven't actually tested that scenario with the stratified substrate work yet. I think it could work. I would probably do a pretty small layer in a big container like that. I think it would just add some drainage at the bottom, and if the rest of it is more of a pine bark based media with some bigger chunks mixed in, you'll be fine.
Shred what you're putting on the base.
Yeah.
Yeah, shred.
The bigger chunks on the bottom, but I don't think there shouldn't be any problems with water moving through it as long as it is properly moistened to start with and you keep it regularly watered.
Okay, thank you.
Mm-hmm. Yes.
Along those lines, a couple of years ago, I went to a garden tour in Kansas City, and these people had like gigantic ceramic pots and so forth. And their tip that they were giving was they had put styrofoam peanuts in the bottom of the pot and then put stuff on top of it to lighten it. Is that a recommended thing or not?
I don't recommend that practice. That would be getting pretty deep into some of those materials, but I prefer to stay organic, so that with organic materials, so that they can degrade naturally over time instead of having these materials that don't break down. Styrofoam doesn't break down, and there's other ways to make your pot lightweight and still be good for plants. Here.
If you inherited a big pot as a palm tree,
the
soil's like a rock right now.
Would not surprise me.
Yeah. So what's the best way to replant it?
Yeah, if it's really big, you're probably going to need a bunch of people to help you delicately remove it out of the pot. You may have to break the pot in order to get it out. It's probably extremely root bound, would be my guess. And it's going to need a bigger pot to go into if you're going to maintain it at that size.
Hard rock or soil?
Yeah, I would put fresh. So, this is an interesting side story, but a friend of mine runs the National Arboretum, and I got to visit a few years ago, and they have the U.S. National Collection of bonsai plants that have been gifted to the United States from other countries, and sometimes they have to repot them. And he was showing pictures of where they had repotted some of these, huge bonsai plants, and they had put some of this material in the bottom, and it was like broken Japanese and Chinese pottery and stuff, but it was just rock hard. And if you want that plant to continue to be able to live, you have to do the hard work of getting it out and giving it a better growing environment with a bigger container with fresh soil and rechecking it. But sometimes you make cool discoveries like, you know, really old pottery that they've put in the bottom of the container. Yes.
Couple questions. First, this.
Wool pellets. Okay.
It's a thing.
Sure.
And
What is it?
wool pellets.
Wool pellets. So that's going to hold a lot of water, would be my
Yes,
guess. And they're pretty big chunks, so they give you some airspace and they would degrade over time.
Right. It's something you recommend putting in your potting soils and.
I have not tested that. My guess would be, again, anything up to 25%. You know, if that's 10%, 5%, 25%, you're probably fine.
And the second question is, we know we're getting something close to 7 to start. We know we're putting on a very alkaline water. Sprinkle some sulfur on top of our various containers to try to keep it stable in that 7 range.
It wouldn't hurt. That can't hurt anything in Kansas, I don't think, as long as you're not overdoing it. I do have some mixtures with some different combos of different ratios of perlite to peat. If anybody wants to look at those, and some of the Eastern red cedar at different particle sizes that we chipped up. So if anybody wants to look at those. Oh, apparently I have sand in here too, because it's real heavy. As if you guys don't know what sand looks like. Turfus is like a clayey. I would say this is probably pretty inert and will not hold a lot of water, but it could provide structure and work for a plant that likes to be dry, like cacti. Here's some of those additives, lime and sulfur and delightful sand. So, and then here's some pine bark. I didn't organize those consecutively, but we can do that in a minute. Are there any other questions that those online can benefit from? Yes.
Appreciate your discussion of plant growth and development of the substrate. I was wondering if you had any specific suggestions about germination. We'll be starting seed here shortly. Is there anything special about the media we might use for that?
That's also an excellent question. So there are germination media. They tend to be either heavily perlite or heavily vermiculite. Those are media that you would use just to get them established, and then you'd move them out of that into a more standard potting media of some kind. But yeah, I mean, there's, depending on what you're growing, if it needs it, if you can skip that step and just go straight to a more standard media for you know, in the case of just starting seeds, that's probably more efficient. But you know, if you have time, you can do both. Okay, well, I'll stick around for a little bit. If you have questions, if you want to come look at the samples, I'd be happy to talk more about potting media with you. So thanks.